According to the National Electrical Code, running cables outside a building is not generally permitted for branch circuits. There are exceptions for specific situations, but these do not typically apply to branch circuits. Specifically, NEC Section 300.22 C4 addresses service conductors, stating they can be run outside a building if they are installed in a raceway or otherwise protected. However, this exception is exclusive to service conductors and does not extend to branch circuits. Inspectors in most areas generally do not permit the installation of branch circuits on the outside of a building, even if they are enclosed within a leader or similar structure. Several code references support this prohibition. NEC Section 300.22 states that conductors entering buildings or other structures must be protected from physical damage. NEC Section 300.3 B requires electrical conductors to be installed in a raceway, an approved cable, or other approved means. NEC Section 334.15 B specifies that cable assemblies shall not be used where conductors emerge from a raceway. There are several reasons for prohibiting external branch circuits. Firstly, protection from damage is a primary concern. Cables exposed to the elements are susceptible to damage from weather, animals, or accidental impact. Secondly, safety concerns arise as touching an exposed cable can be dangerous, especially if it is energized. Thirdly, electrical hazards can occur, as moisture and condensation can lead to electrical arcing and fires. Fourthly, aesthetic concerns exist, as cables running outside a building can be unsightly and detract from the building's appearance. If running cables inside the building is not feasible, consider the following alternatives. 1. Install a subpanel in the attic. This allows for the installation of branch circuits within the attic space, eliminating the need to run cables outside. 2. Use a conduit. A conduit offers additional protection for cables running on the outside of the building, providing a more secure and compliant solution. However, you should always check with your local authority having jurisdiction as to if this is permitted. It is always recommended to contact a licensed electrician. A qualified electrician can help you find a safe and compliant solution for your electrical needs, ensuring that the installation meets all applicable codes and regulations. When installing any electrical wiring, safety should always be a top priority. It is essential to follow all applicable codes and regulations to prevent electrical hazards and ensure the safety of people and property. If you are unsure about any aspect of electrical wiring, consult with a licensed electrician. Using a conduit is a common method for protecting electrical wiring that is exposed to the elements of physical damage. Conduits are typically made of metal or plastic and are available in a variety of sizes and types. When selecting a conduit, it is important to choose one that is appropriate for the application and that meets all applicable codes and regulations. Some common types of conduits include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Each type of conduit has its own advantages and disadvantages, so it is important to choose the one that is best suited for the specific application. When installing a conduit, it is important to follow all manufacturer's instructions and to use the proper fittings and connectors. Conduit should be properly supported and secured to prevent them from sagging or moving. All connections should be tight and secure to prevent water from entering the conduit. Subpanels are electrical panels that are used to distribute power to different areas of a building. Subpanels are typically installed in areas where there is a high demand for electricity, such as kitchens, bathrooms, and workshops. When installing a subpanel, it is important to follow all applicable codes and regulations. Subpanels should be properly sized to handle the load that they will be serving. All wiring should be properly sized and installed according to code. Subpanels should be properly grounded to prevent electrical shock. When working with electricity, it is important to take precautions to protect yourself from electrical shock. Always turn off the power before working on any electrical wiring. Use insulated tools and wear rubber gloves and shoes. Never work on electrical wiring when you are wet or standing in water. If you are unsure about any aspect of electrical wiring, consult with a licensed electrician. The NEC provides detailed requirements for the installation of electrical wiring in buildings. It is important to be familiar with the NEC requirements before starting any electrical wiring project. The NEC covers a wide range of topics including wiring methods, overcurrent protection, grounding, and bonding. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The NEC is available for purchase from the National Fire Protection Association. In addition to the NEC, many local jurisdictions have their own electrical codes. It is important to be familiar with the local electrical codes before starting any electrical wiring project. The local electrical codes may be more stringent than the NEC requirements. The local electrical codes are typically enforced by the local building department. When planning an electrical wiring project, it is important to consider the load that the wiring will be serving. The load is the amount of electricity that the wiring will be required to carry. The load is typically measured in amps. It is important to choose wiring that is properly sized to handle the load. If the wiring is too small, it can overheat and cause a fire. The NEC provides tables that specify the ampacity of different types of wiring. The ampacity is the amount of current that the wiring can safely carry. When choosing wiring, it is important to consider the voltage of the electrical system. The voltage is the electrical potential difference between 2 points. The voltage is typically measured in volts. In the United States, most residential electrical systems are 120 volts or 240 volts. It is important to choose wiring that is rated for the voltage of the electrical system. When installing electrical wiring, it is important to properly ground the wiring. Grounding is the process of connecting the wiring to the earth. Grounding helps to protect people from electrical shock. The NEC provides detailed requirements for grounding electrical wiring. When installing electrical wiring, it is important to properly bond the wiring. Bonding is the process of connecting different metal parts of the electrical system together. Bonding helps to prevent electrical shock. The NEC provides detailed requirements for bonding electrical wiring. When installing electrical wiring, it is important to use the proper overcurrent protection. Overcurrent protection is the process of protecting the wiring from overcurrents. Overcurrents can be caused by short circuits or overloads. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip or blow when an overcurrent occurs. The NEC provides detailed requirements for overcurrent protection. When installing electrical wiring, it is important to use the proper wiring methods. Wiring methods are the ways in which electrical wiring is installed. The NEC provides detailed requirements for wiring methods. Some common wiring methods include non-metallic sheet cable, armored cable, and conduit. When installing electrical wiring, it is important to follow all manufacturer's instructions. The manufacturer's instructions provide detailed information on how to install the wiring properly. Following the manufacturer's instructions will help to ensure that the wiring is installed safely and correctly. When installing electrical wiring, it is important to inspect the wiring for damage. Damaged wiring can be a safety hazard. If you find any damaged wiring, it should be replaced immediately. When installing electrical wiring, it is important to test the wiring after it has been installed. Testing the wiring will help to ensure that it is working properly. There are a number of different tests that can be performed on electrical wiring. One common test is the continuity test. The continuity test is used to check for breaks in the wiring. Another common test is the insulation resistance test. The insulation resistance test is used to check for insulation damage. When installing electrical wiring, it is important to keep the work area clean and organized. A clean and organized work area will help to prevent accidents. When installing electrical wiring, it is important to wear appropriate personal protective equipment. Personal protective equipment includes safety glasses, gloves, and a hard hat. When installing electrical wiring, it is important to be aware of the potential hazards. Electrical wiring can be dangerous if it is not installed properly. By following all safety precautions, you can help to prevent accidents. The NEC Section 310.15 provides guidance on the allowable ampacities of insulated conductors. It includes tables and formulas to determine the appropriate conductor size based on factors such as the conductor material, insulation type, ambient temperature, and the number of conductors in a raceway or cable. When using these tables, it's important to apply any necessary correction or adjustment factors as outlined in the code. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest advances in electrical technology and safety practices. The NEC is developed by the National Fire Protection Association, and it is widely adopted by state and local jurisdictions throughout the United States. The NEC is a valuable resource for electricians, contractors, and other professionals who work with electrical systems. It provides detailed guidance on all aspects of electrical installations, from wiring methods to overcurrent protection. The NEC is available for purchase from the National Fire Protection Association. In addition to the NEC, there are a number of other resources available to help you learn about electrical wiring. These resources include textbooks, training courses, and online forums. If you are interested in learning more about electrical wiring, I encourage you to explore these resources. Remember, it is always best to consult with a licensed electrician for any electrical work to ensure safety and compliance with local codes.